These are very large objects, blazars, quasars. They're all being photographed to have these huge vortices. They're enormous. We see them at all scales. This is a quasar. So here you can see 10 to the 6 light years long is this vortex. That is 1,000,000 light years long. Okay? 1,000,000 light years long vortex. At the speed of light, 1,000,000 years to get to the end of it. And these things are spinning at near the speed of light when they arrive at the event horizon of the black hole. So very, very high torque. Big engines out there that are not being calculated. Now this is the different scale. Those are called microquasars. We find those even inside our own galaxy. And they, in this case, the vortex is only 3 light years long. So now you're starting to see the scalar dynamics, the scale change, the fractal nature of the division of space. From quasars to microquasars to collapsed stars or supernovae, we see the same dynamics, the same vortex. Look at this vortex dynamic on this pulsar, which is a result of a supernova explosion. Have you ever seen articles in a layman physics magazine where it says the death of a star explode into a supernova? Okay. We haven't ever experienced the death of anything. We haven't observed that. We really haven't. All we've observed is things changing state. Okay? For instance, I'm not talking esoterically here. For instance, people have all sorts of debate about if life continues after death or eternal or whatever. You don't need to be esoteric. Just take, what you got and extrapolate from it. You have a few billion atoms. There's a lot of cells. There's 100 trillion cells in a human body. And they're all organized in an organized matter. And then all of a sudden, they disorganize. Okay? However, all these atoms are still spinning. You haven't lost one. Okay? They're still out there. They're still spinning. In fact, you might be made out of the atoms of your neighbor. And your neighbor might be made out of your atoms. And so there's no evidence that things actually stop. Because if there is space-time torque going to singularity in each point, then there is angular momentum at all levels and things continue spinning no matter what. What I'm saying is that the friction that's out there is overcome by the space-time torque. So, and that makes it appear as a frictionless environment. So we don't see death. We just see things changing levels of organization, changing scales. And when we see a star exploding, right, they call it the death of a star. But when they focus on that same area afterwards, what do they see? They see a pulsar. Oh, that's nice. They just changed the name from star to pulsar, so the star is dead and the pulsar is born. Let me give you an example. If you were a camera inside a woman's womb, and this woman was pregnant, you would see life developing in that womb. And after 9 months, you would have probably a pretty good relationship with this life inside the woman's womb. All of a sudden, there's a big earthquake in your world, and waters disappear, and there's an opening that opens in the little black hole at the end of this hip joint, and this being that you had a relationship with disappears through that hole. You would experience death. You would think this being is dead. The person on the other side experienced life crossing the event horizon. Right? So, what I'm saying is that our mathematics and our views have now shown us that actually pulsars and supernovae explosions are the result of stars when space-time is torqued into a certain radius, and it generates material inside, so that the Big Bang is only one of those events that generated the atoms of our universe. That atoms are actually being manufactured at the singularity of black holes. And that's the exchange of those atoms coming out, those vortices, as the space-time torque influence those black holes. And when those particles get out of there, they are stuck in the gravitational field of that black hole and accrete on the surface of the event horizon, as well as other atoms that are created by that black hole as it travels through space. And when it accretes too much material, it becomes unbalanced. There's too much radiation for the contractive torque force at the center of the system. The system slows down too much, and the instability generates an explosion. It blows up. What it does, it releases a layer of material so it can regain stability. And so that's what we see. And then it regains stability, and when it does, guess what? The radius is much shorter, the ballerina has brought her arm in, so the thing spins way fast, like a pulsar.